Welcome to this video. Today, we are going to understand a very interesting and very practical circuit. Controlling a stepper motor using the A4988 driver, fully driven by a couple of 555 timer-based pulse generator. This circuit allows you to control the motor speed, direction, and micro-stepping without using Arduino or any microcontroller. Everything is done using simple components like resistors, capacitors, and a BC547 transistor. Now let's understand the complete system. Let us start by looking at the whole block diagram. On the left side, we have two 555 timer ICs. The first 555 is wired as an astable oscillator, which means it continuously produces a stream of clock pulses. These pulses finally become the step signal for the A4988 driver. The speed of these pulses depends on the RT resistor and the CT capacitor. So, by adjusting RT, you automatically adjust the frequency, and that controls how fast the stepper motor rotates. Now let's learn about the first 555 astable timer, the main frequency generator. In this part of the circuit, the first 555 is configured as an astable multivibrator circuit, which takes power from the DC supply. The timing network made of RT, the 500K potentiometer, and the CT capacitor decides the oscillation frequency. This 555 constantly charges and discharges CT, producing a square wave at its output pin number 3. These pulses then move forward to the A4988 step pin. The pin 3 of the 555 astable circuit is directly connected to the step pin of the A4988 driver. Each pulse sent to this pin causes the motor to advance by one step. As the frequency is increased, the speed of the motor correspondingly rises, while a decrease in frequency results in a reduction of the motor's speed. The central section of the diagram features the second 555 timer, which is set up as a monostable. This monostable is activated by an external push button or switch. Upon receiving the trigger, the monostable's pin 3 outputs a high signal for a predetermined duration, which can be determined by selecting appropriate values for R and C within the monostable. The signal from pin 3 of the 555 monostable is directed to the enable pin of the A4988. It is important to note that the enable pin of the A4988 operates in an active low configuration, meaning that when enable is low, the driver is activated, and when enable is high, the driver is deactivated. To make this happen, we incorporate a small NPN transistor or an inverter to invert the active pulse generated by the monostable. When the monostable output transitions to a high state, the output of the inverter switches to a low state, which in turn activates the A4988 for that particular duration. Now let us see how the direction control using a push button is implemented. Look at the small switch connected to the DIR pin of the A4988. Whenever you press the button, the DIR pin toggles between high and low, which changes the rotation direction of the motor. So, the motor can run clockwise or anti-clockwise simply by pressing the switch. Next, let us see how the micro-stepping setup using MS1, MS2, MS3 is done. On the diagram, you can see MS1, MS2, and MS3 pins. These pins set whether the motor runs in full step, half step, quarter, eighth, or 16th step mode. They can be connected either to ground or VDD, depending on the stepping mode you want. This gives you smooth and precise motor rotation. Now let us discuss about the current control using VREF trim pot. At the bottom of the A4988, there is a 10K trim pot connected to VREF. This trim pot adjusts the maximum current flowing to the stepper motor coils. By rotating the trimmer, you can set how powerful the motor operates. This prevents overheating and protects the motor. Next comes the charge pump and filtering capacitors. On the right side of the circuit, you can see several capacitors like 0.1 microfarads and 0.22 microfarads connected to VREG, ROSC, CP1, CP2, VCP. These capacitors stabilize the internal charge pump of the A4988 and prevent noise or vibration in the stepper motor. Similarly, the big 100 microfarads capacitor near VBB is used to filter the motor power supply and reduce voltage spikes. Now we will learn about the motor output section. The A4988 has two full H-bridges inside it. Out 1A and out 1B go to one coil of the motor. Out 2A and out 2B go to the other coil. Each sense line goes through a low-value resistor, typically 0.1 ohm. These sense resistors allow the A4988 to monitor coil current for accurate micro-stepping. Finally, let us summarize the full working of this circuit. So, to summarize, the first 555 generates frequency. The second 555 enables the operation of the circuit for a specific duration of time and then turns it off. The button controls direction. The trim pot adjusts current. The A4988 handles microstepping. And the motor receives smooth, regulated movement. This circuit is perfect when you want a simple, Arduino-free stepper driver with adjustable speed and direction. And that brings us to the end of this explanation. If you found this demonstration helpful, then do not forget to like this video, comment your questions, and subscribe for more electronics tutorials like this. Thank you for watching, and I will see you in the next video.